Section 9.4, Arithmetic Series. The objective is to define arithmetic series and find their sum. A series is the indicated sum of the terms of a sequence. So we worked with sequence the past couple of days. A finite series has the first term and a last term. So here's an example of a finite series. Let's say we start with a term 6, then it goes to 9, then it goes to 12, then 15, and then 18. So if you notice, they have a first term of 6, last term of 18. It doesn't go any farther than that. An infinite series continues without end. So here's an example of an infinite series. 3, 7, 11, 15, and then it keeps on going forever. So infinite series goes on forever. Finite series ends. An arithmetic series is a series whose terms form an arithmetic sequence. When a series has a finite number of terms, you can use a formula involving the first and last terms to find the sum. Here's the definition box on that page. The sum of a finite arithmetic series. The sum S sub n of a finite arithmetic series. So in the past couple of lessons, we've been looking at A sub n. That's a term. S sub n indicates a sum. So make sure you're paying attention to those letters. A sub 1 plus A sub 2, keep on going up to A sub n. A sub 1 is the first term, A sub n is the nth term, and n is the number of terms. We need a formula here that I forgot to put on there, or it got deleted. Write this down. S sub n equals n divided by 2. That would be the number of terms divided by 2. Parenthesis, your first term, which is A sub 1, plus your last term, which is A sub n. So let's practice using that formula. What is the sum of the even integers from 2 to 100? So first of all, let's look and see how many terms we have. We need to find that out. We also need to find out what the first term is, and we know that for sure is 2. We know that the last term is 100, so A sub n equals 100. But we do need to know, whoops, that didn't go in the right place. We do need to know how many terms this would have. If we take 100 and divide it by 2, we're only looking at the even integers. There's going to be 50 of them. You don't want to, list those all out and figure it out that way. So following the formula, we have 50 terms. And so 50 goes in for n. My first term is 2, and my last term is 100. So the 50th term would be 25 times 102, and we multiply that out, and we get 2,550. So what I'm looking for when you guys are doing these is what is your setup using the formula and what is your answer. If you can do all of that and just type it in your calculator, go for it. If you want to pause right here and try the got it question, you can. What is the sum of the finite arithmetic series starting with 4, 9, 14, 19, 24, and so on? So again, we're looking for a sum. Oops, we don't know that yet. Our first term is 4, so A sub 1 equals 4. Our last term is A sub n, that's 99. Right now we don't know how many terms there are. But if you take 99, subtract 4, and divide it, there are 20 integers. And that would be adding 5 every time. So this is an add 5. add 5, and so on. So even if you look at it at like this, there's 100 terms here, and if you divide it by that common difference, that would give you the number of integers. So 100 divided by 5 would give you 20. So number of terms, my n is 20. All right, so s sub 20 would be 20 divided by 2. My first term is 4. My last term is 99. So the 20th term would be 10 times 103, and that would give me 1030. Again, give me the answer. Also give me the formula that you used to get the answer. I do not want you to keep writing s sub n equals n over 2 times a sub 1 plus a sub n. Put the numbers in there, please, so I know exactly what you're using. Here's an application question. A company pays $10,000 bonus to salespeople at the end of their first 50 weeks. If they make 10 sales in their first week, and then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in week 50? How many did they make in all 50 weeks? So the only thing that really doesn't have anything to do with it is this $10,000 bonus. We're not going to use that anywhere in our formula. What we're really looking at is their first 50 work weeks, 10 sales, and things like that. So how do we decipher what these things are? The first time it actually would change their income is if they make 10 sales. So we're going to actually count that as our first term. It's going to end when they make their 50th sale. So a sub n is going to be 50. Their sales are going to differ by 2 every time, so that common difference is 2. So for this one, we're going to take a sub n equals our first term, a sub 1, plus the number of terms minus 1 times the common difference. So that formula should look very similar to what we did a couple days ago with arithmetic sequence. So we want to know what is a sub 50. A sub 1 is 10, so I'm going to plug that in. My number of terms is 50. I'm going to subtract 1 from it. My common difference is 2. A sub 50 is going to be 10 plus 49 times 2. So my 50th term is 108. So this person made 108 sales in the 50th week. They want to know how many sales did they make altogether. So now we turn it into, in all 50 weeks, this is a series, where this one right here was just a sequence. Okay, so for the sum of 50 times, we're going to use the new formula that we got today. 50 divided by 2. My first term is 10. My last term is going to be this one. So in the first week, they had to make 10 sales. In the last week, they will make 108 sales. And we simplify that. We get 25 times 118, which is 2,950. By the end of that 50 weeks, they will have made 2,950 sales. If you would like to pause right here, we can practice the got it question number 2. The company above has an alternative bonus plan. It pays $5,000. So remember, even though they tell you what this income is, it's not really necessary in the question. If a new salesperson makes 10 sales in the first week, and then improves by 1 sale per week each week after. So this is your common difference. That would be 1. This would be your first sale or your first term. And one salesperson qualified for this bonus with the minimum number of sales. Week 50 would be your last term. Okay, so again, we're going to use the term formula, arithmetic term. So we want a sub 50 Our first term again is 10. Our common difference is 1. So we're going to go 10 plus 50 minus 1 times 1, because that's our common difference. 10 plus 49 times 1 is 49. So after 50 weeks, this person has made 59 sales. Okay, so that's how much in 50 weeks. How many altogether? Again, that's a series. We want the sum of them. So we're going to take, and I should have changed that to 50, S sub 50, 50 divided by 2, and then we're going to take our first term plus our last one. And remember, we get that from the answer that we just found. So 25 times 69. In 50 weeks, this person has made 1,725 sales altogether. So one answer leads to the next one. Now that's if you have a finite number of numbers. What happens if you don't have a finite number of numbers and it's infinite? That means you can't tell what that last term is going to be. So there's another formula that we're going to follow to do that. Now, initially I only wanted this sigma symbol right here. It doesn't need this little box, but I couldn't get rid of it, so I just left it. This is called the Greek letter sigma. With it, use the limits to indicate how many terms you are adding. So when you have an infinite number of numbers, or even just something that's a higher number than you want to list, you could use sigma. The limits are the least and greatest values of n in the series. So maybe you know the first item in the series and you know the 1,000 first item in the series, but you don't want to write them all down. Here's a new method of finding that. So this means from the third term to the 108th term. So right here, this is your lower limit. This right here is your upper limit. And this right here is your explicit formula. So how do we use that? When you're looking at it, the first number that goes in is a 3. So you plug a 3 into that n squared formula and you get n squared. So this is your first term. Then you go up to the next, you go up by 1, which would be 4. So you plug a 4 into the explicit formula. And this would be the second term. And you'd keep on going up to the 108th term, which would be 108 squared. Okay, so let's look at this one. So my first term, 7. My last term is 207. I need to come up with a formula in order to actually use my summation symbol. So what I'm trying to fill in is this. My first term is 7, so I'm going to go, and it's always counting by terms, not the actual item that you start with. So I'm going to go from n equals 1 up to something. I don't know how many terms there are right now. We're going to find that out here in a minute. So I know that my first term is 7. I know that my last term is 207. I also know that I can figure out what my common difference is. So 11 minus 7 would be 4. 15 minus 11 would also be 4. So my common difference is 4. Okay, so I'm going to go back to my terms. A sub n equals the first term plus n minus 1 times that common difference. A sub n equals my first term times n minus 1 times my common difference. So that's really all that I know right now. I'm going to simplify that just a little bit. 7n minus 7. Oops, I forgot my Okay, I forgot my plus in there, so go back. Sorry about that. I'm thinking that doesn't look right. Okay, so a sub 1 plus n minus 1 times d. Okay, so my first term is 7 again. My n minus 1, I don't know how many terms there are, but I do know that the common difference is 4. So this is 7 plus 4n minus 4, which simplifies down to 4n plus 3. This right here is my explicit formula. Okay, so let's write our sum. My explicit formula goes here. Actually, I can move it closer. Now I need to find out how many terms there are. So I know what my last term is. It's 207. And I don't know what term that is, but I could find out by setting it equal to my explicit formula. So I'm going to subtract 3 from both sides and divide by 4. N equals 51. So we're going to go from 1 to 51, and we're going to plug in a 1. We're going to plug in a 2. We're going to plug in a 3, and we're going to keep on going, and that should give us the series that is listed up here. So if I plug a 1 in there, I got 4 times 1, which is 4, plus 3 is 7. If I plug a 2 in there, I get 8 plus 3, which is 11. If I plug a 3 in there, I get 12 plus 3, which is 15. If I plug a 51 in there, I get 4 times 51 plus 3, which gives me 207. You can always double check and make sure this is right. You should never get it wrong, but the first part is definitely the hardest part in finding what that explicit formula is. If you'd like to pause right now to practice these got it questions, you can. So got it number 3. What we need is our first term, which is -5, our common difference, which when you look at it, you'd say 2 minus a -5, which would be 7. 9 minus 2, which is 7. 16 minus 9, which is 7. So my common difference is 7. Now I'm going to plug it into my sequence formula. A sub n equals a sub 1 plus n minus 1 times d. I'm going to make it specific for this one. A sub n equals -5 plus n minus 1 times 7. Simplifying that, we get -5 plus 7n minus 7. And that gives me a simplified formula, -12 plus 7n. So far, my formula would be -12 plus 7n. I need to find out how many terms there are, so I'm going to use my very last one, 268. So 268 equals -12 plus 7n. You could really, just plug it in and use the last one. We're going to add 12 to both sides, which gives me 280. And then we're going to divide by 7. So the number of terms that we have is 40. Do that in purple. And you do have to show your work. Coming up with this magical formula all on your own will not cut it. You do have to show all of this. Using the proper formulas. Okay, let's try one more. B goes 500, 490, 480, and so on. So my first term is 500. My common difference would be -10. 500 to 490 would be subtracting 10 every time. So my formula, a sub n, is my first term, 500, plus n minus 1, times my common difference of negative 10. I'm simplifying. So you get 510 minus 10n. Show these, please. Okay, now I want to know what is the number of terms that I have. So I'm going 10 equals 510 minus 10n. I subtract 510 from both sides and I get negative 500. I divide by negative 10 and I get n equals 50. So I get 50 terms starting at 500, going down to 10, and I have my explicit sequence as well. So here's what it looks like. So n equals 1 to 50, and my sequence is, or my series that's going to start with this sequence is as follows. That's 10n, not 10 sub n. There we go. And you could plug this in to see if it matches. 510 minus 1 would be 500. If you up it to 2, it would be 510 minus 20, which would be 490, and so on. Now, how do we actually use one of these to get to the sum of all of them? Obviously, we don't want to write down all of them. There must be some way to find what we're looking for. So what we're going to do is use our formula. S sub n equals the number of terms, 70, divided by 2. Our first term, and you might have to go off to the side to find these, a sub 1 would be 5 times 1 plus 3, which is 8. So my first term goes in here. My last term would be a sub 70, which would be 5 times 70 plus 3, which is 353. We're going to plug that in here as well. So my series is 35 times 361. So my sum is 12,635. Again, I want the answer. I also want to have you plug it into a formula. Here's another one. So we are going with, I have 7 terms. I'm going to show you 2 different ways to do this one. I'm going to spread this one out a little bit. Okay, so we're going to take 7 and divide it by 2. I need to know what's my first term, what's my last term. So a sub 1 would be 1 minus 1 squared, which is 0. My 7th term would be 7 minus 1 squared, which is 36. So I add those 2 terms together, and I get 3.5 times 36, and I get, calculate this one, 3.5 times 36, which is 126. Which I don't think that worked. I'll look at that one in a minute. If there's a small number of terms, I might have to go back and disregard that. I'll look at it in a minute. If there's a small number of terms and you want to write them all out and add them together, that is certainly an option. So what we're going to do is we're going to plug a 1 in here. Okay, so if I plug a 1 in there, I get 1 minus 1 squared. Then I get 2 minus 1 squared. then I get 3 minus 1 squared, and so on all the way up to 7. So 1 minus 1 squared is 0. 2 minus 1 squared is 1. 3 minus 1 squared is 4. 4 minus 1 squared is 9. 5 minus 1 squared is 25. 7 minus 1 squared is 36. And when I add them all together, I get 91. Now, this other formula should have worked. My first term is 0. My last term is 36, so that matched. I am going to have to cross that out. I'm going to look at that tonight, and I'll see why that didn't work. I'm not really sure what happened there. Because we had the first one and the last one together, which we did. I'm going to look at that beginning formula really quickly. Okay, I'll look at it tonight and see what happened. Sorry for the delay here. Okay, here is the last set of Gotta questions. If you want to pause and try them, go right ahead. So 40 divided by 2, because we have 40 terms, or the top is 40. Our first term would be 3 times 1 minus 8, which is negative 5. And then we're going to add to it my last term, which is 3 times 40, which is 120, minus 8 is 112. So negative 5 plus 112, whatever the answer that is, it's 107, times 20, and you get 2,140. Make sure you use your formulas and plug them in accordingly. For this one, this is a short enough little series. Let's just write them down. So the first time through, we're going to plug in a 1. We're going to cube it. I'm going to flip up to the next counter, 2 cubed. The next counter would be 3 cubed. And the last counter would be 4 cubed. So it's 1 plus 8 plus 27 plus 81, I think. 64, sorry. And then we add 1 plus 8 plus 27 plus 64. And we get a sum of 100. If you're putting them all out there, make sure you write them down as well. And I think we're just going to skip this one for today and call it good. I'm going to look at that one that I couldn't get the 2 formulas to work out. I'll let you know tomorrow. Watch the video and come with questions.